Hi, this is Gunjan, and today we are going to do some statistical analysis, a basic statistical analysis. The beauty of data sciences, and particularly with Python, is if you see, we have so many sensors and data is being collected at a phenomenal pace these days. How do we make sense out of those data? How do we create models for our machine learning unless we make sense out of data? And that's where your statistical analysis comes into picture. If you have a patient and he has a monitoring device attached to his body, and that monitoring device is capturing the data and sending it to the database, how do we make sense of that data? When to trigger the warning, when not to trigger the warning. So that kind of information requires a statistical analysis to be done at a phenomenal pace. And Python helps us do that. Let's get to it. I have a data set, cars.csv, a very small one with 32 records. Let's import that. I'm creating a data frame. I am using a method read underscore CSV. My data set, which I have downloaded from GitHub, and I want to print my data frame. Here it is, the data for different models of car, the numerical data, so that we can take sum, calculate mean, calculate median, calculate standard deviation or the variance, find out the maximum of which particular row is having the maximum value. We'll get to it. So what I've done is I've taken the data and I've put it in an Excel just to do the basic maths as well to understand if it's correct. So there are 32 records, 0 to 31. First thing that we want to do is we want to take the sum. So cars, that's the data frame, and the method is sum. Here it is. For MPG, I'm getting the value as 642.9. For MPG, I'm getting 642.9. That is the sum of all the columns, if all the column values. So if I take this 642.9, so that's what it's giving me. Next, I want to take the mean. For MPG, I'm getting 20.09. And again, average is 20.09. Mean is nothing but the average. Let's say I want to take the average not vertically, rather horizontally. All I need to do, as we have been doing, is x is equal to 1, which means column. So 29.907273. Let's go and check. 29.90. So this is the mean value of all the values MPG, CYL, this for Mazda RX-4. Don't ask me how do we make sense of this data. I'm just telling you that in case you have a data set where you need to do the addition or find a mean horizontally, then you can do it this way. Let's get to the median. Median for MPG is 19.2. If you remember the basics from your school arithmetic, what median is, if you have a set of numbers, you arrange them in an ascending order, and if they are odd set of numbers, then the middle number is the median, and if they are even set of numbers, then the average of the middle numbers is your median. Again, we are going to take MPG, but first we want to sort the data. Largest, here it is sorted. Now I'm going to number them so that I know how many records are there. So I have 32. So basically I'm looking at column 16 and 17, and I'm going to average the values. So 19.2 average is 19.2, and that's what your median is. Next, I want to take the standard deviation. Let's first get it, and then I would explain as to what standard deviation means and why is it important for calculation. If you see, for MPG, we have the standard deviation as 6.02, while for DISP, it is 123.93. What it means is the range of numbers that you're having, how far away are they from the median? That's all. That's all it means. For an instance, if you have 8, 6, and 4, they don't seem to be too far away on the number line, right? But if you see this, the range itself is the max value would be, let's say, somewhere around 472, and the min value is somewhere around 79. So the range is pretty wide, and that's where you see for DISP, the deviation from the median is pretty high. Similarly for HP. And if we take a column, for instance, gear, which is 3, 4, 5. So the standard deviation from the median is pretty low for the rest of the numbers. So that's what standard deviation is. And similarly, it correlates to your variance. And you can do cars.var. And this is your variance. So you can calculate the variance for all the MPG values. Similarly, all the cell values. That's what it is. Now, next, we want to, for all the MPG values, I want to find out which particular row has the max MPG values. For that, I'm going to create a variable or data frame. MPG is equal to cars. I forgot the data frame name dot MPG. Now, this is the column. And next, I want to have MPG dot IDX max method. So here it tells me that the 19th row is having the maximum value. 19th row, when you arrange it in when it's in the original format, if you take a look at it, in the original format, the 19th row is having 33.9, and that's the maximum value. Of course, we have not arranged it or sorted it ascending to descending, otherwise it would not make sense to take max. Without sorting, we want to know which particular index value is having the maximum. So 19th row is having 33.9, and that's what I get to know from this one. Next, for instance, I have a column called gear, and there are 3 values. So my values are repeated, and I want to know how many cars are having 3 gears. For that, I would create a data frame gear. You can name it anything. Is equal to cars data frame dot gear column. Next, gear dot value counts. So 15 cars are having 3 gears, 12 are having 4 gears, and 5 cars are having 5 gears. Now you can ask me, Kunjan, I don't want to do all this. Can you tell me a simple method to get all the information, statistical information directly? So I'll say cars.describe. Here you have the count of MPG, mean of MPG, standard deviation, min, 25%, 50%, 75%, max, all the data on your fingertip, just with one method. Thank you.